Hello, welcome to another LeetCode problem. Today we are going to solve another media problem 669, trim a binary search tree. So basically in this problem, if you read the description, they have given two important low and high numbers. Say if any node value doesn't belong to these low and high, we need to remove that particular node, and then again we need to assign the remaining nodes to the existing tree. And keeping in mind that we have to make sure that it is a BST, so anything on the left hand side is lower than the root value, and anything on the right hand side is greater than the root value. So that's a property of the binary search tree, right? Now if you look at this example, the given example here is the low is 1 and the high is 1, and then given BST is if we take the in order traversal, that's going to be 0 and 1, 2. But since if you look at this BST, 0 doesn't belong into the range, right? If you in the lower, which is lower is 1 and high is 2, so they trim this particular 0, and then remaining 3 is this one. Same for this particular example. We need to find the nodes which are not in the range, and then delete those nodes, and then assign the remaining nodes to the tree. Now the challenge comes when how do you decide which side of the node you need to assign. Let's say there is something on the left hand side also, left and right hand side also, right? How do you say, okay, you need to only assign the right hand side to the 3 if you don't need to assign anything on the left hand side? Same for this one also, right? If you have right or left, or if you have both the nodes, you need to think how do you traverse and then uh, assign to the parent node. In this particular example, you need to use the property of the BHTs. That's where it is going to be quite useful, because let's take example and see how do we solve this problem. So first example, we are given like so low is, let's say low is given as 1, and then high is given as 2. So low is 1 and high is 2. So definitely in this tree 0 will be removed, and the only remaining tree is 1 and 2. But how do I approach this problem? So what we'll do is we'll take help of the BST property. So let's say we start with the root node, right? Root node. Now see if root node value, oops, root node value is either less than or greater than high, is or whether in the range of low or high or not, right? If it is not in the range, then definitely we have to remove this particular root value. If it is range, then we just need to traverse tree further down and see whether if any other nodes are remaining which needs to be removed or not, right? So what we are going to do is, let's say when I traverse the first node, and then in this first node I found that 1 basically belongs to the within the range of 1 and 2. Now next I do a DFS traversal, let's say pre-order. So in this node I reach to this particular node 0. Now see whether 0 belongs to this 1 and 2 node. No, 0 doesn't belong to 1 and 2 node. So what I have to do is, so since it is a BST, definitely anything will be on the left hand side will be less than 0, and anything on the right hand side will be greater than 0, because it's a valid BST, right? So definitely anything, let's say there is a further node as -1, and this is another, I have to put something between 0 and 1, because it has to be greater than 0 and less than 1, right? Let's say 0.5. So this 1 -1 is also going to be less than the what is my low value, right? And then but it is definitely the right hand side is going to be greater. So what I'm going to return is this particular node to back to the tree node. So I won't travel on the left hand side, I'll only return the right hand side node. Let's take example, uh, let's say better example. Let's say 4, 5, let's say 4, 5 and 6. Okay, uh, let's say my low is equal to 3, I so is equal to 4, right? Now I reached to this, I traverse the tree and I reached to this particular node, right? So for on the right hand side I have 6 which is greater than 5, and then 4 which is less than 5. Now I compare with the high first. Now I compare this high, since see this 5 is greater than high, right? 5 is greater than high. So definitely any node which is on the right hand side is going to be greater than high. So all the tree on the right hand side is basically useless for me, because I don't need to go and further do a check on the each node value. Using BST property, I'll automatically come to know that anything on the right hand side will be useful for me. So I'll only travel on the left side, because that falls into that there is a possibility that left hand side will fall into my uh, low and high range. So I'll just return null everything null from here, and then I'll go and traverse this particular tree, so that in case of greater, I'll just go to the tree dot left, basically root dot left, and then I'll do a further check. When I come at 4, I see 4 belongs to the range, then it's all good. Then I'll do further down tree. If there is a nodes present, then I'll go further down in the tree, and then I'll keep doing this until I reach to the solution where there is nothing left uh, for the trimming. Same for this example, you start with the root node 3, and then you go on left and right. So once you go on the left hand side, as I explained, is a valid BST. You found 0. So in this case, let's say what is a criteria. So criteria is 1 and 3. So your low is basically 1 and high is equals to 3. So you have to remove nodes, basically your 0 and 4. That is those are nodes that needs to be removed, right? So once I reach at the 0th node, I found this is 0th node doesn't belongs to this range. Basically 0 is less than the low. That's the condition I found. Okay, so definitely if anything present on the left hand side is also going to be less than the low. So I only travel on the right hand side, because there is a possibility the right hand side is going to be in the valid range. So when I traverse the right hand side, I found 2, and 2 belongs to the right valid range. So I'll return here, which will be assigned to 3, and then in this case 4 belongs to null, because 4 is greater than high, right? And then further when I traverse in the tree, there is nothing left and right, so it will return basically null. So it will be null will be assigned to 3, and then 2 will be assigned to this but left, because the call came from the left hand side, so 3 will be assigned to the left hand side. So this is the logic here. I think we have to, so the answer is basically we have to use the BST property, and then we keep traversing the tree based on the root value, and then we compare them. So if I look at the code, it's actually pretty simple. So you start with the root node. If it is root node, just if it is none, root node itself is none, you just return none. That's a base case, and then you compare the low with the low and high. So in this case, let's say if you start with 1 is less than low, no, right? Because 1 is equal to low. So you just go to this particular condition, and then you traverse further left or further right, and then whatever the return value is, you assign it back to the from on the left hand side, basically from where you're calling. The result will be assigned back to that particular node. So you go to the further left, you came here on the 0. 0 is less than low, yes, that's correct. So you further then, because 0 is less than low, I know that then everything on the left hand side will be less than low, so I have to travel only on the right hand side. So I'll travel the right hand side. The right hand side there is nothing, so it will return null, because it's in the right hand node, it is empty. And then I have also attained a return value here, right? So it will assign back to the root dot left, basically from where the call came from. Same way from the right hand side, for 1 2 belongs to within the range, so nothing will happen. And then finally it will return the final tree, which is updated tree, because we have updated left and right node here, and then that tree will be written as a result. I hope you understand. Let's try to run it. So it works fine. So as I explained, it will do the traversal, trim down the nodes, and then return null values so that the tree is updated. You can just go ahead and submit the solution. Okay, 94% works pretty well. Thanks for watching.